Good morning, folks. How are we all doing today? I hope well. Thank you, Wei Tai. That was really pretty impressive. The data you have there is really great. I can begin to talk about this as soon as I see my slides appear on the screen. There we go. My name is Larry Waters. I am the owner and founder of Electrify My Home. We do, just like the name says, we do electric conversions only. The only thing we do with gas appliances is pull them out and put a cap on that line. We're really proud of that. We also have a training program that we are contracted through the Tech Clean California to help inspire other contractors to hopefully install heat pumps in a more thoughtful and efficient way. Next slide, please. The biggest question right here when we're talking to people out in the world about heat pumps is, what if your next furnace wasn't a furnace at all? How do we get to this conversation with our consumers so that we can open up the doors to more heat pumps? One is to design them the right way so that the outcomes are good, so that the word gets around organically. At my company, we focus on designing them in a whole different way. And I'm going to share a little bit of that with you and some of our thoughts on the types and benefits, what we call good electrification, and our principles of install small. Next slide, please. Well, what's wrong with gas? I think everybody on this call probably understands the big six, right? So we have the major one is carbon monoxide and health risk. We have lots of opportunity to improve this in our homes. A lot of us starting with the gas range. In my particular application, my wife finally agreed to a new induction stove once she found out what was coming out of the gas burners. Rising costs are also helping us right now get the message out. You know, high utility bills are a great motivator at this point. You know, and furnaces have these inherent maintenance problems. There's more parts in there. They really need to be looked at kind of often, safety checked once a year, just to make sure that they're not emitting pollutants, and you know, cleaned up and taken care of. Heat pumps are a lot less maintenance as far as that goes. Furnace systems typically need a lot more ductwork and bulky duct systems that are often installed in inhospitable locations like your attic space or under the floor, where we have to use a lot of capacity of the system just to keep the ducts neutral during the times that we're conditioning the house. Air pollution, something a lot of people don't know, is oversized furnaces often cycle on and off a lot. And I hear it from customers all the time say, I have a great furnace. It heats my house up in a minute and a half. That's probably an oversized furnace for all you that are wondering. And a furnace really has to run 20 minutes before it reaches steady state. And before the furnace reaches steady state, it's never operating at the way it was designed to operate. So the exhaust coming out of the flue pipe, as well as the heat coming out of the furnace, is never what it's designed for until it reaches this steady state. And most furnaces cycle off way before they reach steady state. And because furnaces use such hot air to heat the house, it often creates leaky and inefficient thermal changes within the building envelope. So all of these things are important to discuss with the customers as we're moving them towards electrification. Next slide, please. So there's some common residential heat pump technology. Unitary, you know, most of the systems that are put in today are unitary solutions. They're kind of a little bigger and clunkier, and they're what we would call the traditional heat pump technology. They've been around since, you know, the 50s and 60s. And, you know, if you talk to an HVAC technician, you can probably get them to tell you about 3 or 4 heat pump horror stories they have with these old traditional solutions, yet we're still installing them the most of anything. Most of them are 1 to 2 stages. In other words, they operate in 1 or 2 different capacity ranges. And most of the ones that are installed are base efficiency. And for a base efficiency system to be installed, it often needs up to 6 breaker spaces. This is a big deal for us at Electrify My Home because we talk about being good stewards of your electrical panel. Most of the systems we install just take 2 breaker spaces. And then, the unitary equipment has a loss of performance at lower temperatures. So when it gets below 40 degrees, oftentimes these systems are going to lose a lot of their efficiency and capacity. And the auxiliary strip heat that some are installed with might kick in to support continuing heating the house. Next slide. Next click. What we're going to talk a little bit about and what we like is the air-to-air inverter systems. They come in mini split technology like wall mount. We've heard a couple people mention this morning already. Ductless and ducted. Ducted is what we like the best. And then multi-zones systems and their application. We'll go a tiny bit into that. Next slide, please. Inverter versus traditional. Inverter wins every time. Traditional systems just cycle too much. They let the house dictate the capacity. And that's not a great way of being energy efficient. So if you see in the graph here, we see the system turning on the left. The orange line is the system turning on and cooling the house down to the preset temperature line that's in the middle, and it often overshoots. If we have a traditional system in our house, we've felt this before, as the furnace gets warmer than the house is looking for, and then the house gets cooler between cycles. This is what happens with traditional heat pump systems, except we use a lot more energy doing this. And sometimes during the afternoon, if we allow the house to get hot between cycles, the house can heat up quicker than the capacity can bring it back down. Next click, please. Inverter heat pumps work way different. They give you optimal control. Once again, we start the unit, it gets down to room temperature, but instead of turning off and overshooting, it slows way down when it hits this temperature, and it makes minute adjustments throughout the day to keep the house at that specific temperature. And because we have these longer run times, there's lots of benefits that come from that. One is we get really great opportunity for indoor air quality because we're moving air over a longer period of time. So drawing it through a good set of filters really increases the indoor air quality in the house. So with a properly installed inverter heat pump system, we can kind of not worry about those smoky days and not worry about having to keep our windows open and just to, not broil inside our houses when it's smoky outside, or running 16 filters inside the house. This is going to take care of it on a whole house level on the way we do them. So it gives us optimal control and keeps the set point temperature. Next slide, please. We've coined this phrase and we teach it to all of our student contractors that good electrification is something that we need to focus on. And we share that good electrification is installing the most efficient solution for that customer. This is going to be super critical over the period of time that California is transitioning to electric. This is going to cause a significant drain on the grid. And the more efficient systems we put in now, the less effect we're going to have on the grid later. We also need to consider adding more loads and the space and capacity needed in our electrical panels. So we teach that we need to be a good steward of the electrical panel and really look through the process and plan the process out for the customers. And consider all the electrification requirements from the start. When we're visiting our electrification prospect, we share with them their complete path through electrification and help them understand what steps are going to be necessary, what order to do things in, and also how we're going to address the loads in the electrical panel. We use a lot of circuit splitters and things like that so we can share breaker space. And we want to not ever in our company be the catalyst for the electrical panel upgrade. Next slide, please. Guess what? I'm assuming that everybody in here, when HVAC people see this picture, we all kind of chuckle. And it's really sad that this project could be so bad, but it's a great picture to show you just how bad things can be. This is not good electrification. Taking these furnaces out that you see in this picture and simply installing heat pumps in their place is not going to be a good way for customer satisfaction or energy savings. And things like you see the little duct kind of hanging over the rafter in the attic there. These situations are in houses everywhere. And we need to learn how to understand what this means and fix these problems in order for heat pump application to be beneficial and be successful. My biggest fear is that we have a lot of heat pumps installed incorrectly, and it causes a bit of a bad taste in consumers, and electrification doesn't come out to be everything we would like it to be. So being careful and doing it correctly is really important. This is bad electrification. Next slide, please. With heat pump inverter, mini split inverter technology, there's lots of options, and we can use this super efficient technology even if we're doing a direct replacement of your gas furnace. We don't have to put the systems on every wall, and we don't have to change the way you experience your comfort in your home. There are options available for us to just put a heat pump system right in place of where your furnace was before. But it's really important, if you look at page or picture number 1, it's really important for us to do this properly. And you see there's some details on this, like on the left of the picture, you see the high efficiency filter, the squared around and the very large return air duct. The ductwork is all sealed and installed properly. And this is all important for us to keep the efficiency of these systems up by reducing pressures within the system. In picture number 2 here, you see an application where we installed one of these in an attic space where there was a regular furnace before. You can see once again, just to the right of that picture is the high efficiency filter and the very large, properly sized duct system on a very small system. Both of these systems here are less than 1.5 ton capacity and less than half of the capacity of the system we removed. So we're able to get these systems in much smaller and more efficient. Next slide, please. This particular application lets us, this particular technology lets us use a bunch of different applications. So we can fit systems into areas that didn't traditionally have them very easily with this technology, including number 6 there is just a built-up system in a master bedroom closet. And we ran the ductwork inside the building and went out the sidewalls, and we were able to condition a space that normally would not have been able to be conditioned in that way. Notice on the left, number 5, the system, the line set, and the customized plenums, the very large return air. And we like to cover all of our ductwork up with insulation. So picture 3 and 4 are before the insulation is installed. 5 shows one where we had to get to the other side, so it wasn't all able to be covered. Next slide, please.
Larry, you have about 1.5 minutes left.
Okay, you got it. This is my favorite customer in the world and her load calc. She lives in Berkeley on Norvell Street. She has a 1,000 square foot house. We put an 18,000 BTU system in. We pulled out a 60,000 BTU furnace that she didn't use because it was like a freight train coming through the house. And she will tell you how awesome this is. Next slide, please. So right-sized heat pumps bring big benefits. Sizing these things right and installing them thoughtfully is really important. And we're able to deliver really good comfort, really low sound, very, very quiet systems, a super environmentally friendly system. They're much safer, and we can provide great indoor air quality because our systems tend to run longer and we can draw our air across those filters longer. Next slide, please. There you go. Now that's good electrification.